So you're interested in learning a little bit more about Linux. Well, let's get started with a little bit of history. So back in 1991, that is when Linux was starting to be developed. And it was being developed by Linus Torvalds. I think I said that correctly. He was a young computer science student, and he was tired of dealing with licensing issues that companies had for their different operating systems and software and things. So he decided that he wanted to start developing his own operating system, is what it comes down to. And in the long run, this actually changed the software industry basically forever. All right. And it came out of a need for himself and wanting to do something for everybody else, for all the other computer science students to use. And of course, everything needs some sort of mascot. So Linus decided that Tux the penguin, as you can see on the screen, would be the mascot for the wonderful world of Linux. And why do you think he picked this? Well, because he was bitten by an angry penguin as a kid on a visit to Canberra, Australia. All right. And so that's why he ended up picking Tux. All right. He is definitely the mascot for Linux. You see him a lot or all over the place. Now you may be asking, all right, Linux, whoop-de-doo, who uses this? No, very few people, that I know, or if any that you know, actually use Linux on a daily basis. And for that, you'd actually probably be mistaken. Well, yes, they probably do not use it as their daily driver. It's not the computer they sit at when they go home and play video games or you watch YouTube or whatever the case is. But it is actually used basically every time you execute a search on the internet, watch a video on your phone, or order something online. Linux is actually working in the background there. Also, if you're using an Android phone, that is based off of a Linux Unix system. So you might actually be using Linux more often than you think. Linux is used basically like everywhere. All right. But the cloud is definitely a big proprietor to using Linux. One of the other interesting facts that I heard at some point was that supercomputers, the top 100% of supercomputers use Linux. Now, what's the top? I don't know. I don't know if that's 10, 20, 50, 100. I don't actually know how many supercomputers are even out there. But the statistic that I heard was that the top 100% of supercomputers Linux, and I find that to be an awesome fact. Now, today, Linux is, Linux today compared to Linux in 1991. I mean, we are over 30 years ago. It's 33 years ago, roughly. All right. But today, Linux is not a whole lot different from what it was back then. Linux utilizes and expands upon many of the commands and ways of accomplishing Compunix that Unix began with. All right, so it is still using those roots from when it was initially developed, and some of that source code, from my understanding, from when it was initially developed, is actually still being used today, which is very impressive. The amount of lines or code that to run Linux in the background has gone up significantly from what it used to be. But so is a lot of the computer processing and capabilities. So it kind of makes sense that we go hand in hand with that. So, um, yeah, so I said about 30 years ago, some of those commands are still being actively used today, which is really nice. Linux is also a revolution of evolution, allowing you to learn the majority once and keep up with small percentage of changes in a continuing learning process. So what that means is you learn it today. And in 5 years, if you would come back to Linux and if you still have that memory, you might still be able to use a good bit of what you already know to get back into the wonderful world of Linux. So it's really kind of this neat thing to see how it has progressed over the years and has not changed that drastically in the long run. So that takes us to the kernel, right? And the kernel is a deep portion of what Linux actually is. I'm realizing we skipped a page. No, we did. So the kernel. And the kernel has 4 main jobs, all right? And those are memory management, and that's the whole keep track of how much memory is used to store what and where, all right? It is there to process management, to determine which process can use the CPU and when and for how long. Device drivers, so to act as a mediator / interpreter between the hardware and the processes. And then the system calls and security, so we're going to receive requests from the service from the processes. So those are the 4 main jobs of the processor, or not the processor, of the kernel. All right. And as you can see from the little picture on the right here, the kernel is sitting right in the middle of everything. All right. So you've got applications that talk to the kernel which talks to the CPU, the memory, and the devices, and this is all bidirectional. So everything's going back and forth between the kernel. So without the kernel, a lot wouldn't be getting done. So it's a very important piece of code that is sitting there. So that is what the kernel is. Now, what do most people think of when you hear of kernel? Most people refer to Linux. They're usually referring to the combination of software called the GNU, and Linux. All right, and that's what defines the operating system. All right, not actually the kernel. All right. So there is definitely a little bit of give and take going on here in the long run for all these different things. Now you may be going, GNU, what is that? All right. Well, let's start on the right side. So GNU was created back in 1983, so about 8 years before Linux itself was created, right? Because we said 1991 is when Linus started working on Linux. All right. This was originally designed to be a complete operating system. All right, that was their goal. They said, okay, we're gonna create a new thing here, and we're gonna go with an operating system, and we're gonna go from there. Well, in the long run, by the end of this all, the operating system is not what GNU was, but it was in the long run. They determined they were better at just building tools and software to be used alongside Linux-like OSs, like Linux ended up being. And kind of the interesting thing is GNU is an acronym for GNU is not Unix. So it's an acronym of an acronym of an acronym because it's constantly being itself. So GNU, it's the G, is not an Unix U. So it's just kind of this never-ending acronym system here, which to me is kind of a silly thing, but that's what they decided to go with. Now, what is Unix? Unix is a system that was developed by AT&T Bell Labs back in the 1970s. All right? And the big benefit here is it is written in the language of C. Now, C is one of just many programming language, and if you were interested in computer programming, it's definitely a good one to learn. As of the 2023, the specs that I have in front of me, um, the C language is 19.34% of the programming languages used. So almost 1/5 of all programs written are written in C. Now, there's also C++, which is 22.42%, which is a variation of C. So that's, by the time you look at all these variations of C, you get up into almost over half of all computer program, or half of the languages that people are using is based on C. So it's really quite a large group of operating systems, which is really quite nice. It is and Unix is written in C. I think I said that already. But it's a very modular and portable compared to most other OSs at the time. So it is very easy for them to go from one computer to another and keep things moving along really nicely. And I know I talked about how Linus is the creator of Linux and he was a computer science student. This was just a hobby project for him. And this was back in 1981. And the one thing that Linus did do was he adopted all of the requirements to be qualified as a Unix operating system, but he isn't certified. So technically, it is Unix-like. It's not actually Unix, his Linux system. So it was technically qualified. He could have gone through the process, but he decided against it. So. All right, and that takes us to open source. Now, open source is something that hopefully you have all heard of before. All right, and what is open source? Open source is software, or really hardware at this point, that is the source code or files or whatever is open for anyone who can to inspect, modify, and enhance. And this to me is a really cool thing that we have this capability that people are willing just to say, yep, here's some software. It's something I wrote as a project, or I got paid to create or whatever. But it is free, so you can just download it as you like. And if you think you want to make some changes to it, well, you are allowed to do that as well. So that is a huge benefit to me. I love the open source world. It's definitely a nice culture. And the big thing about open source is it wouldn't exist without you and I and all these other people who just say, yeah, I want to create something and here, have it. All right. If everybody was a greedy person, we would not have open source because then everything would be called proprietary. And that is that only the original authors of proprietary software can legally copy, inspect, and alter the software. All right. So it is definitely, a whole different world. So like Microsoft Office, that is a proprietary Office tool. Now, if you want a open source version, there's LibreOffice, Libre. That is an Office tool that was built, I'm assuming, to basically be like Microsoft Office, but to be a free version of it so that anyone can download it. And what are the big benefits here? Well, the flexibility. Anybody can modify the code to fit your need. Now, depending on the licensing agreement, that yes, there is still licensing agreements for open source software. Um, Depending on the licensing agreement, if you change the open source software, you may be able to keep that as a your own little gig and not have to publish the code, or you may have to publish the code that you altered for whatever purpose. So it is a little bit of a give and take going on there. But I like to believe that people who are using the open source and modifying the code are goodwills in the long run. But anyway, it's very flexible. It's a, hey, I really like that I have this capability, but I really need to put 2 lines through text instead of a single strike through. Well, with the open source, you could modify the code to give you that opportunity if that's something that you really wanted. So it's a really kind of a cool thing in that world of flexibility. It's also very cost effective. You can scale the software to fit your needs. So you're starting with this open source software and you're like, okay, we only need this little itty bitty portion of it right now, and you just use that. And then as your company grows or your needs grow or whatever the case, whatever it is growing, you are able to then grow that software to fit your needs of your company or individual or whatever the case is. The other thing with cost effectiveness is oftentimes the software itself is going to be free, which is huge. It's like, okay, it's just no licensing fee. It's just download, install it, and you're good to go. I know someone who works for a very large company, and they've got a nice budget for software and things, and he could, very easily request, software that he would need. But he has found that it's easier just to find the open source software, especially software as a service, SAS or SaaS, where you're just using things through your web browser, because then he doesn't have to go through the whole process to actually request the software and get the software installed and did. So he just is like, oh, I just do everything I can in the web browser. That is his opinion, and I don't blame him. It's definitely a big benefit when you don't have to get IT involved to install software, and then the purchasing department to buy software and those types of things. So there's definitely a big benefit to open source software in that aspect. The problem with open source software, though, one of them, well, is one of the big disadvantages here. We'll come back to some more advantages in a minute. Is support. Oftentimes, open source software, because it's just Joe Schmo creating it or whatever the case is, there's not a support department. You can't just call them up and go, "Hey, I'm having this problem. Can you fix it?" And he can go, "Well, yeah, but it's going to take me 2 months because that's when I have free time." All right. So it is definitely a little bit of a give and take going on there. So even though it's very cheap, you may have to have a separate support contract to help you support it. And I just told you there were no support contracts. No, I didn't say there's no support companies. I said it doesn't come with support. So there are companies out there who are dedicated to supporting these open source software. So they are experts themselves on the software, and then they're helping you as you need it. So really, again, kind of an interesting system there of company A invents software, or person A, but company B is the one actually supporting it. So it's a different model, but again, you can fit those support contracts to your need. It's not a one size fits all. So that's again huge benefit. Some other benefits, we've got solid information security. So we're all afraid of all of our data getting hacked and all our accounts getting hacked and someone getting in and doing whatever it is that they're not supposed to be doing. And yes, that is a horrible thing. But with open source software, and this is definitely a pro and a con, or it's an advantage and a disadvantage, the code is available. So that means that anybody can open that code up to try to find those security holes. The benefit here is you have people who are security researchers looking through these things, trying to find those loopholes, and then they work with the company to get those loopholes patched. So that is definitely a big benefit here, that they're actively searching and then getting these things patched. The downside is if some not so good people who are looking at the source code trying to find these holes, and they do find one, they don't tell anyone about it. They now have a hole to everyone's software who's using that. So definitely it's a little bit of give and take. But the big thing is that when problems are found by those good-willed people, oftentimes the holes are fixed very quickly. So big benefit there. Also, when it comes to development speed, right? Oftentimes, and you probably haven't worked in a software environment, but if you ever have done any programming and things, it takes a lot of time. It's like, okay, we got to write this, and we got to test it, and we got to fix it, and we got to test it again and fix it, and it's just going back and forth and back and forth and back and forth. And that can take a lot of time. But the benefit of making something open source and just giving the source code to everybody, well, you now have probably maybe not just you, but you could have millions of people working with you to create this code. There's all these people who believe in this project or they want to add their own little flair to it because they want this functionality. They're all going to work. So there's going to be lots of people using and finding problems and solutions. So that is another big advantage here for getting new functions added and things like that. It's not as much of a small team as a large group of people who are going to be working with it. Next, we have distributions. All right. And a distribution is basically a package deal. So it includes the kernel, it includes tools, and it includes a suite of applications that you might be interested in. And over on the right here, I have a picture of 16 different distributions. Now, is this all of them? Oh, no, no, no. There are tons and tons and tons of different options out there. So if you're going to get into Linux and you're thinking about trying to install it on your own, you have to go and research and try to figure out which one it is that you think that you want to use. And that is going to make a huge difference in the long run of how easy things are for you, how much support there is out there, and all those other wonderful things. Distributions make it very easy to get started in Linux. You don't have to know the command line. You don't have to do a lot of things. If you pick the right distribution, there is going to be tons and tons and tons of support. And most likely, someone else has already tried to do the same thing you're doing, and there is support on forums and things like that for you. So if you're like, okay, I'm having this problem, you do a good Google search or Yahoo or Bing or whatever companies you like to use, and you're going to find that, oh, here's someone that had that same problem. This is what they did. Now, you always have to take that with a grain of salt because just typing random commands off the internet is not the best idea in the world. You never know what they're going to do, so it's always a good idea to research what they're telling you to do and what the command that they want you to type does. All right, but it is definitely an option out there for you. And also, all these distributions have different purposes. All right, some of them are going to be standard desktops. All right, like Ubuntu, Linux, Mint. Actually, probably basically everyone on here is meant to be a traditional desktop interface for you. So just like your laptop or your computer that you sit down at has a nice, pretty graphical user interface that you're going to use, and it works. If web browser should just work right off the bat. All right. Many of these will also have server setups, all right, which are going to vary what's the suite of applications that gets installed by default. Basically, most of the servers that I know have some sort of web server installed with them, so that way you don't have to install that separately. Maybe Apache or I can't think of the other one off the top of my head, but it doesn't matter. They're going to have different applications, is what it comes down to. All right, and then you also have distributions that are meant for specific industries that have specific tools for them. One of the big ones in the cybersecurity world is called Kali Linux, and it comes with most of the security software that you'd want to use to try to either get into something that you're not supposed to, or break password encryption, or whatever the case is. All right. So we have different purposes for all these different distributions. So again, you need to find which one is the one that you need. If you're a big gamer, Linux Mint, I believe, is a good option for you to get into. All right. The other thing that most Linux distributions have that they've had for a long time, I believe since roughly the late 1990s, maybe early 2000s, is package managers. Now, you all may be referenced, think about package managers. There's app stores, all right, where you're like, okay, I can go and I want to install, again, a web browser, or I want to install a web server or a game or something like that. You can always start with the package manager, and that would be my suggestion for you. Because the package manager handles a lot of the background and hard things for you. It's like, oh, here, you want to install OpenOffice. Okay. You also need these 12 other applications installed so we can run OpenOffice. And it just installs everything at once for you in the background, which is a really nice thing. All right. So again, like late 1990s, early 2000s, somewhere around there is when the package managers kind of became a standard thing. Yeah, so this is a lot longer than Apple and Windows had package managers. So kind of a big deal in my opinion there. Now I did just mention GUI, all right, and that would be your graphical user interface. That is the interface that you interact with to use your computer. All right. This is one of two ways that we interact with computers nowadays. Basically, all desktop operating systems that I've ever used have a nice GUI associated with them. I can move my mouse, I can click on things. I've got my icons in the bottom corner here that I can say, oh, I want to have a pen. I can, open up a pen and I can circle things. All right. Um, that is your GUI interface. It's graphical. It allows you to use a mouse and a keyboard to interact with it. You can move around. You can drag applications. You can resize things, menus. It's a very nice, easy way for us to interact with our computer. Um, and this is like the third iteration. All right. The first innovation, the first way we interacted with computers was not a GUI. It was the command line. All right. So CLI, command line interface. And that's what I have over here on the right. This is a text-based interface. So it relies 100% on your keyboard. Your mouse, not even used. You don't even technically need to have a mouse plugged in with the command line interface because it really doesn't do you any good in basically all instances. So it relies purely on your keyboard for interface. All right. So as you can see here, the command that was run was pwd, which is print working directory. And then they asked for help. So they wanted the help file for that command. And it tells you what it does. It gives you options and all those things. So you have to know every command it is that you want to type out. It's not a perfect system by any means. But as you become I'm going to call it a super user, more better at this, and you use it more and all those lovely things, you will be amazed at how quickly that you can do things in a command line interface compared to doing it with a graphical interface. When you start loading all the shortcut keys, and you're like, okay, if I start typing something and I hit tab, it will fill in the rest of the command or file or whatever that's in the directory that I'm in, up to the point where it duplicates with something else. So if I had two files, one was called hello and one was called hello world, and I typed hello after an ls command or whatever, it would fill. If I started typing out hello he and I hit tab, it would type llo, and I could say enter and launch the hello, or I could start typing world after that, hit tab again, and it would then fill in the world part because it's now going, hey, this is the only file that you have called that. So it's a very powerful tool once you learn how to use it. The biggest benefit here is scripting. All right, that last bullet. This allows us to write commands that we can run basically whenever we want. So instead of having to, say, oh, I want to check my email, and you open up the email manager, you could say, okay, every hour on the hour, check my email, and it opens up and downloads them for you, and instantly just prints them out on the screen or whatever the case it is that you want to do with it. Or you say, check my email, and then if there's an email from so-and-so, then pop up a notification on my screen or whatever, put a little asterisk in the command line or something like that. So it allows you to write scripts or little bits of code to simplify your life. And simplifying is definitely a very important thing as far as I'm concerned. I am doing the best I can in the world we live in to script as much as I can, including making my syllabuses for class. I don't manually go modify this every semester. I have an Excel sheet with a script that runs that automatically changes the dates. It updates my office hours. It does all the things for my syllabi, so I don't have to think about them anymore. I change everything in one file, and I hit a button, and it creates all my syllabuses for the semester. And it saves them to the right place, so that way it updates them for you guys, so opening them on D2L, and it just makes my life a lot easier. So scripting is a wonderful thing. Now, is it hard? Yeah, it can be hard, especially if you don't know what you're doing and you're trying to learn a new language or whatever the case is. I will openly admit that the amount of time that I put into my syllabus script was way more time than I would probably put in 2 or 3 years in manually changing my syllabuses. But in the long run, it will save me time because I don't have to think about it anymore. It takes me all of 3 minutes now to update all of my syllabuses without me even thinking. I just hit a button and I can be checking my emails while that's happening. So scripting is a very powerful tool. I did tell you that there was a third option. So we had command line interfaces. This is the first one. And GUI was the endpoint. And there was one point in the middle, which was a menu-driven system. It was kind of a GUI, but you still didn't have a mouse. All right. So instead of you having to know all of these, and I don't have a picture of this, You were able to just like go to a menu at the top, like you press Alt key or whatever, and that'll jump you to the menu and allow you to say, okay, I need this command, and you can navigate through some choices to then find out what command options there were available to you. So there is a third option there. But for the most part nowadays, we are at the command line or we are at GUI, and that is kind of the two big ones. And most people are GUI. All right. When you start getting to power users and server people and things like that, that's when you start getting into the wonderful world of the command line. All right, and that's a quick introduction to Linux.